Hi, hello everyone. Welcome back to my channel. I'm again here with a new topic. Myself Shrindi, I'm a student of CSC Data Science Department and currently I'm pursuing my engineering at Sri Venkateshwara College of Engineering, Bangalore. In this video, we are going to learn about vector calculus. Vector calculus is a topic which comes under mathematics. Let us see about introduction to vector calculus. Vector calculus is a branch of mathematics that deals with vector fields and vector functions. It extends the concepts of calculus such as derivatives and integrals to vector quantities. Vector calculus is used in various fields including physics, engineering and computer graphics. Now let us see some basic concepts of vector calculation. As we have studied in earlier classes, that vector is a quantity that has both direction as well as magnitude. In vector calculus, vectors are represented using bold-faced letters or with an arrow on the top. Vector can be added together, multiplied by scalars and have a direction and magnitude. As we can see in this figure that the blue arrow mark stands for vector quantity which have both magnitude as well as direction. Now coming to vector functions. A vector function is a function that takes an scalar input and produces a vector as an output. Vector functions can be differentiated and integrated similar to scalar functions. Vector functions are commonly used to represent physical quantities like velocity and force. Vector function is a vector whose components are real value functions of a common variable, usually t. We have seen a vector function before. The parameter equations of a line like r of t equal to x naught plus at comma y naught plus bt comma z naught plus ct. A general function of vector function would be vector of t equal to f of t dot g of t dot h of t. Now moving on a topic gradient. A gradient of a scalar vector function is a vector that points in the direction of the steepest increase of the function. It is denoted by a symbol del and is defined as a vector of partial derivatives of the functions. The gradient is used in optimization problems and determining the direction of the maximum change. Now let us see about the divergence. Divergence is a measure of the spreading out of a vector field at a given point. It is denoted by a symbol del dot f, where del is the del operator and f is the vector field. Divergence helps in analyzing the behavior of the fluid flow and electrical fields. Divergence of vector field. Let us take divergence of vector field A is measure of how much a vector field converges to or diverges from a point in volume. Divergence of a vector field A is defined as divergence of A is equals to del dot A. Now let us move to the topic curl. Curl is a measure of a rotation or a circulation of a vector field of a given point. It is by a symbol del cross f, where del is represented as del operator and f is represented as vector field. Curl is used in analyzing fluid dynamics, electromagnetism, and in computer graphics for creating realistic effects. Now let us discuss about line integrals. What is line integrals actually? Line integrals are used to calculate the work done by a vector field along a curve. They involve integrating the dot product of the vector field with the tangent vector of the curve. Line integrals are used in physics to calculate the work done by a force and in electromagnetism to calculate the potential difference. Now moving on to the topic surface integrals. Surface integrals are used to calculate flux, which measures the amount of vector field passing through a surface. They involve integrating the dot product of the vector field with a normal vector of the surface. Surface integrals are used in physics to calculate the flow of fluid through a surface, and in magnetism to calculate the electric flux. The topic vector calculus is almost based on physics. Like we can find fluid, flow of fluid, we can calculate the electromagnetism, we can calculate the electrical flux, and so on. Now let us see about where the vector calculus can be applied. Vector calculus is widely used in physics, as we have already seen in previous slide that it is almost based on physics to describe the behavior of motion, forces and fields. And even it is also used in computer graphics also. Like it has application in engineering for analyzing fluid flow, electromagnetism and structural analysis, which all comes under the topic physics. Vector calculus is also used in computer graphics for modeling and simulating realistic effects, and it is also used for computer graphics even. Now moving on to the conclusion. In conclusion, a vector directed in two dimensions has two components, that is, an influence in two separate directions. The amount of influence in a given direction can be determined using methods of vector resolutions. Vector calculus is an essential mathematical tool for understanding and analyzing vector quantities. It extends the concepts of calculus to vector fields and vector functions. With its wide range of applications, vector calculus plays a crucial role in various fields of science and engineering. Thank you one and all for watching the video till the end. Please like, share and subscribe my channel.